everyone. I am thrilled to welcome you to our Applied ML Summit, where we're exploring ways to accelerate machine learning development with high predictability. We have a lot of great content that we are sharing today during the event, so be sure to check out our agenda for a complete rundown of the schedule and the sessions that you may be interested in. Today's summit wouldn't be complete without a little bit of swag. Our wonderful sponsors have some amazing free giveaways for you, so just head on over to our sponsor showcase to claim them. And a special shout out to our premier partners, HCL Technologies, NVIDIA, SATA, and Slalom. With that, let's kick off our keynote. Joining me today is our VP of Cloud AI, Andrew Moore. Welcome, Andrew.
Thank you, Priyanka. It is great to be here.
I am so excited to speak with you today because I want to know how central is the role of AI and ML in digitization, and what are we seeing as challenges faced by the data scientists in order to adopt machine learning and AI?
Enterprises across the globe are looking for ways to digitize operations more quickly, and they're doing this by adopting AI. However, according to Gartner, only 10% of organizations have more than half of their software engineers trained with machine learning skills. This shows a significant gap in the skills needed for developing machine learning-powered applications. Even then, let's say your company is in that lucky 10% and has the machine learning skills needed. What happens when you want to deploy models to production? According to Gartner, on average, only 53% of products actually make it to production.
So really, it's all about two main things that we are hearing from those staggering numbers. One is the skills gap and the abstracting of technology dependencies so more people can participate in the process of machine learning development. And then two, if you have those skills and if you are building the models, how do you make them so you deploy them in production and not just experimenting? As a data scientist at heart, the next question I have for you is, how do you see different users, their needs, and the kinds of tools that are required to be successful in this art of machine learning and AI?
Very good, yeah. So the way I see it, there's four big paradigms that we need to really work on to get us to this machine learning utopia. And I'm going to go through them carefully because we've been designing lots of our technology exactly because of these needs. The first one is freedom of choice. A data scientist is going to need to be able to mix and match all kinds of different machine learning components. Yeah. They want to be able to use different kinds of deployment instances and different kinds of processes. So it's really important that they should be able to pick and choose and not be freaking out about the potential cost differences or the expense of different kinds of machine learning frameworks. All right, so the second thing that we're really worrying about here are meeting users where they are. So my proficiency in my machine learning skills, whether I'm really comfortable with the pre-trained APIs, or if I'm happy to use AutoML, or if I'm an expert who really does want to build my own custom models, which state I'm in should not be the great gating criteria for whether or not I can take part in a machine learning driven company. All right, the third part of this is about the relationship between data and AI. And I don't want any more debate. It's not like, oh, I'm going to build data first and then worry about AI, or I'm going to do AI and then worry about how to feed it data. It has to be done together as one system. And so pushing the tools for data management into AI workbenches is critical.
Yeah.
Now, finally, fourth item is all to do with managing the machine learning models over time with ease. I don't want data scientists to have to spend their time being infrastructure engineers or operations engineers just in order to make sure the models are being kept accurate all the time. I don't want them to have to be experts in managing scaling, disaster resistance, and security, given that the world is changing all the time. I want data scientists to do data scientists, and I want our technology to support the subsequent deployment.
Yeah, to making it easy for them to just do their job, which is gain insights from the data.
Yep.
That's amazing. Thank you for diving deeper into those 4 paradigms. And now that we have those nailed down, how is Google Cloud helping basically invest in some of these paradigms and bringing the management of production machine learning models easier and more approachable to the ML engineers and data scientists?
Very good. So we have lots of people working together on supporting enterprise machine learning. And the sort of guiding principle that we're all using is help customers get rid of every barrier in the way of deploying useful and predictable machine learning at scale. So that mission really focuses us, and of course it's what resulted in May 2021 of us announcing the general availability of Vertex AI. And this is our managed machine learning platform, and it's very specifically designed to accelerate the deployment and maintenance of serious machine learning models. Using Vertex AI, data scientists can fast-track machine learning model development. And in fact, we've seen both development and experimentation accelerate by 5 times and with 80% fewer lines of code.
Wow.
So in the year since launch, customers across many industries have successfully accelerated this deployment of machine learning using Vertex AI. Through Vertex AI and BigQuery for data management, we have seen 2.5 times more machine learning predictions generated in 2021 than in the previous year. And additionally, customers are seeing huge value in being able to actually operate this kind of integrated AI and data. And it's best represented by a statistic that I'm really proud of: 25-fold increase in active customers using Vertex AI Workbench over the last 6 months. So we're really encouraged by this adoption, but we continue to work with our customers and partners to expand the thinking around the challenges data scientists face in accelerating deployment of machine learning models in production. What I'd like to do next is we're going to talk to Smitha Shyam, Director of Engineering for Uber AI, and work with her to get an understanding of how Uber is working with Google Cloud on machine learning. Welcome, Smitha.
Thanks, Andrew, for inviting me.
So let's begin. Can you share what your role is at Uber?
I lead Uber AI. We are the centralized AI machine learning group at Uber. Now, across Uber's lines of businesses, we use AI extensively to make billions of decisions. And my teams build the end-to-end ML platforms, called as Michelangelo, vertical solutions in computer vision, optimization, personalization, and targeted ML engagements across Uber's mobility, delivery, and freight businesses. I also drive our company-wide efforts around ML ops and ML training and education programs.
All right, thank you. Can you walk us through Uber's vision on how you're actually adopting deep learning at scale?
Sure. Before we get into deep learning, let me speak a bit about the importance of machine learning for Uber. Now, ML is critical for us to understand the context in which our businesses operate, be it about the rider, earner, eater, and marketplace in general. And this helps us better serve our customers. When one opens the Uber app, the ETAs that you see on rides and eats, search and discovery experiences, restaurant and dish recommendation, mask verification, these are all powered by ML. Overall, we make billions of real-time machine learned decisions at a global scale. Now, when we started modeling 7, 8 years ago, we started with traditional machine learning techniques. But as we matured as an organization and as deep learning technology has matured, Uber AI has made a concentrated push towards driving deep learning adoption within Uber. The scale at which we operate, the amount of data that we have, and the generalizations that we can benefit from, deep learning fits our use cases beautifully. While it's not the answer for every scenario, For several of our use cases, we have seen benefit by making this transition to deep learning. We have developed a lot of techniques in-house as well as in partnership with companies such as yours to help us make this transition.
All right, so what about the collaboration with Google Cloud? Is that helping sort of complement Uber's current machine learning investments?
It's a good question. At Uber, we have built a very mature machine learning platform, Michelangelo, that supports all aspects of end-to-end machine learning, from collaborative development environment, feature engineering, training, serving, model management, lifecycle orchestration, experimentation support, so on and so forth. At the same time, we are also very cognizant of the fact that as an industry, AI ML is still in its infancy, and the envelope of end to end machine learning is rapidly expanding. So we've built Michelangelo, keeping this in mind to be API first, modular, and plug and play, so that it's relatively easy for us to incorporate a specific component from a third party player in order to complement our current offerings. And a great example of this is the collaboration we have had over the last year with Google Cloud, incorporating Vertex AI, AutoML, and tablet capabilities into our platform.
Excellent. So let's talk about the new machine learning challenges that Uber's facing, especially in the space of structured data. And how are you collaborating with Google to solve them?
Many of our use cases, Andrew, are structured data, and depending on the use case, this data can be imbalanced or we may have to impute missing data. Now, one of our goals is to reduce the time to ship the next iteration of the model. And we have a lot more machine learning problems than ML experts. So, to accelerate, we are collaborating with Google Cloud to incorporate Vertex AI AutoML into the training phase of our platform. In addition to model performance boost, in some cases, there's also dev time savings, and we can use this to benchmark our in house development. And this partnership has been mutually beneficial. For your teams, it has enabled them to solve their dataset size limitations, moving from single instance to distributed training, feature imputation, and customizations.
Thank you, Smitha. Thank you to Uber in general for choosing Google Cloud as your AI and ML partner. We really enjoy innovating with you.
It was a pleasure to be here.
That was so insightful, that Uber partnering with Google Cloud and how you're thinking together about the challenges of data scientists in general. And then based on this strong traction that we're seeing in the market with customers and partners, can you give us a sense of how that is impacting our roadmap in this space?
Ha 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 ha. Excellent. All right, this is where it gets fun. We're going to go through the big announcements exactly on the subjects of these four paradigms, what we're doing about each of them. So let's begin with the first paradigm, freedom of choice. So we partnered with NVIDIA earlier this year, and we were able to announce the availability of the one-click deploy of NVIDIA AI software solutions straight into the Vertex AI workbench. So this feature means that we got a really simple deployment of Jupyter notebooks, and it goes from over 12 complex steps to a single click. So there's another aspect to the power to choose. We are thrilled to announce the availability of an important new technology, Vertex AI Training Reduction Server. And this supports both TensorFlow and PyTorch. So what is this? It's all about using a more advanced bandwidth reduction and latency reduction within these big multi-node NVIDIA GPU clusters. And what it gets us is very significantly shorter times to do the equivalent training job. So you've got the choice to benefit from this. You can either have the same length of deployment window overall and go through more iterations of training jobs, or you can just get done sooner. So really pleased about that. Let's talk about meeting the users where they are. So thanks to you, Google Cloud AutoML is the top automated machine learning framework in the market. So we're really, really elated by this. However, we are well aware that there's more control needed. Every time I talk to someone about AutoML, it's a happy conversation, and then it's like, but bloody hell, I wish we had more control. So we have really listened here. We're announcing the preview of what we call Vertex AI Tabular Workflow. And this is a full managed AutoML pipeline. It comes with a variety of proprietary algorithms like TabNet included, and it lets you go in at multiple levels into AutoML to either control a little bit or a lot of the automation of your network structure, hyperparameter, model selection types of approaches. And we can still do it scalably, so it is quite possible to work on data sets of over a terabyte without losing the accuracy or stability. I want to talk about the third paradigm, data and AI working together. And here, we want to make sure that no matter what the form of the data coming into the AI engine is, we're able to help developers be efficient. Today, we're announcing the availability of serverless Spark on Vertex AI Workbench. And this is the thing which allows data scientists to launch a serverless Spark session within notebooks and just straightforwardly, interactively develop code. In the space of graph data, we're really excited to announce a data partnership between ourselves and Neo4j. And this is the thing which unlocks the power of graph-based machine learning models. So to be clear, what this does is it means that data scientists can use raw data of the form of connected entities which point to each other in big complex webs, convert them into the kind of structured features you need in a machine learning model, and then deploy them within Vertex AI all in one big unified platform. I'm going to now jump to unstructured data, things like images, text, audio, and so forth. Here, we're announcing a partnership with Labelbox. And this is all about helping data scientists actually be able to work with unstructured data efficiently so that the labels on unstructured data can be used directly within machine learning algorithms. Now, this integration is only available on Google Cloud, and Labelbox and Vertex AI, I feel, have really created now a flywheel for helping fast model development with unstructured data. Now, do you remember the fourth paradigm? This is managing and maintaining machine learning models over the long term. It's critical. In my experience, often my big machine learning teams, more than half the effort goes into what happens after you've first launched. So a kind of tool which really helps keep a machine learning system safe and healthy over years are explainable AI solutions. And today we're announcing the preview of Vertex AI example-based explanations. So this explainable AI technique helps you understand if you're getting mislabeled examples coming through, you're wondering what's going on, or if there's some kind of anomaly in your training data. It's, in my opinion, the perfect tool for diagnosing or helping you do the detective work to figure out what's happening.
Wow, so exciting. All of these announcements. I can't wait to get my hands around them. Having said that, data scientists, ML researchers, and experts across the industry are already using Vertex AI to accelerate their model development and putting predictable models into production. So now I want to take a look at some of the organizations and companies that are using Vertex AI today.
Great.
Let's dive into that. Wayfair accelerated large model training jobs 5 to 10 times with Vertex AI. And with Vertex AI, Wayfair's data science team can now increase experimentation, reduce coding, and ultimately move more ML models into production. With Vertex AI, Cruise has also been able to train hundreds of models simultaneously using hundreds of GPUs every month.
And if I can interject, those are really huge models.
Yeah, these are also, they go back into the paradigms you were talking about earlier and making things faster and easier in production level models. With Google Cloud AutoML, Seagate achieved a precision of 98% as compared to 70 to 80% precision achieved from custom ML models. Lowe's is using Vertex AI to create accurate hierarchical models that help balance between SKUs and store-level forecasts at more than 1,700 company stores. Working with Google Cloud and NVIDIA, Cash App was able to deliver 66% improvement to the time it takes to complete a core ML processing workflow. And this goes back to that last paradigm of like, how do you make it easy and predictable to build these models and put them into production?
So we've got lots of customers doing interesting things with Vertex AI. So now we're going to hear from Brian Goodman. He is the Director of AI and Cloud at Ford. And we're going to talk about the impact they're seeing from the use of Vertex AI. Welcome, Brian.
Hi, Andrew. It's great to be here.
Brian, to start, I'd really like to give it a sense of your role at Ford.
Sure. Thanks, Andrew. Well, I lead a team that is responsible for the AI platform and tools at Ford and for developing advanced AI products and services. Ford has one purpose: to help build a better world where every person is free to move and pursue their dreams. AI is critical for that. And as we're leading the revolutions in electrified, connected, and automated vehicles, we're finding that we're using AI everywhere. In fact, sometimes people ask me, where are we using AI at Ford? And it's easier to answer where we're not using it. Some examples: we're using it as we design new and innovative products in the design process. We're using it as we scale our manufacturing with quality. And increasingly, we're using it in our products, as these products sense and respond to the world around them. We even use it on weekends as we have fun with helping the Ford Performance team optimize their race strategies. I never thought I would be a fan of NASCAR, but I find I enjoy watching it now.
Excellent. So let's talk about the partnership between Google Cloud and Ford.
Sure. Well, Ford has invested heavily to modernize our data systems. And of course, like many companies, we have a tremendous amount of data. So we've really relied on Google Cloud to scale this. All vehicles now are connected. Every Ford vehicle we've sold for the last few years is connected just like a smartphone. That's allowed us to transition from a previous model where we had it very transactional. We would sell or lease a vehicle and then hope to hear from somebody someday again. Now we have an always-on relationship with customers where we can constantly improve the products. In some ways, we can update maps as construction happens in real time and changes the roads. We can adapt the range estimates as weather might change and affect the performance of batteries. The volumes of data we're dealing with are just unprecedented and require technologies such as BigQuery to scale. Because of that, the number of people using AI to engineer and build solutions is growing into the thousands at Ford. Google Cloud provides a range of easy-to-use tools that many people can use quickly and tools that allow our power users to push the boundaries of what is currently possible. In one example of that, we're using deep learning to replace the traditional physics-based computational fluid dynamics models in virtual wind tunnel tests. That allows us to make sure that we have the most aerodynamic products possible, especially important for electric vehicles.
Right, so specifically in terms of accelerating machine learning deployment, can you give us a sense of how Ford is currently using Vertex AI and how you see this is going to evolve over the next 12 months?
Yes. Vertex AI is an integral part of the Ford machine learning development platform, including accelerating our efforts to scale AI for non-software experts. For example, we're using Vertex pipelines to build generic and reusable modular machine learning workflows. These are useful as people build on the work of others and to accelerate their own work. For low-code and no-code users, AutoML models are useful for transcribing speech and basic object detection, and we like that there's integrated deployment for trained models. Really helps people to get things into use, which is important. For power users, we are extensively leveraging Vertex AI's custom model deployment for our in-house models. And everything they're doing is it's ideal for data scientists and data engineers not to have to master skills in infrastructure and software, such as Terraform or managing Kubernetes clusters and building APIs in order to productionize their models. This is critical for growing the community of AI builders at Ford, and we're seeing really good success with Vertex AI. It's just core to what we're doing, and we very much look forward to the great things we've heard about today and innovations in labeling and the workbench and third-party integrations.
Thank you, Brian. We are really thrilled with this collaboration.
Oh, thank you for having me.
So for our audience, as you can see from all we've spoken about today, accelerating the deployment of machine learning in production with high predictability we think it's a game changer. So this is why we're building Vertex AI together with you.
I love that word, together, because it is truly a partnership. Thanks for joining and giving us the insights into what's coming next. And I can't wait to get my hands on those awesome announcements. For you all I can say is that we are just getting started. All through the day, you can join us for hands-on labs, breakout sessions, and customer architecture sessions to learn more about the exciting space of accelerating machine learning deployment in production with Google Cloud. For now, stay tuned for our end-to-end walkthrough of Vertex AI coming up next. Be sure to stick around.